So my name is Vinicius Senger. I work as a developer advocate for AWS. But before, I was doing a lot of Java stuff in banks for Brazil. So we did a lot of mainframe integrations with Java in 2004, doing like EJBs in production. At that time, I do remember that we had one of the biggest Java enterprise workloads in the world running in this bank. And it was around 1,500 requests per minute. And that was the biggest workload. Like even some microsystem, oh wow. So, and it's amazing because this mainframe connector is still in production, running with EJBs. So, and it's very, very used by the Brazilian population because it's a public bank. So Java code can survive a long time. That's the first lesson we need to figure out. Like when you design an architecture, think about that the software can maybe survive more than you know? So we have in our menu, I like to cook, so we have lessons that we learned from Amazon.com, AWS, and also small businesses that are using Java. And we had the privilege of kind of mentoring some small companies and also learning from Amazon and AWS Java engineers how we upgrade our Java workloads. If you are not aware, Amazon and AWS, we are one of the biggest Java users. Everything that gets serious at Amazon, we move to Java. So we are heavy Java users. We also we did a lot of things to have Java in our specific workloads, including like reducing the object header. We start reducing to 4 bytes in the past to save memory. So we did a lot of innovation with JVMs the past 10 years to achieve our goals. And we want to show and discuss some open source solutions. I'm always pushing for open source, but then sometimes we need commercial tools for doing that. We were going to discuss software inventorying, modernization process, and then Jonathan will bring a very interesting topic around performance optimization using AI. And also we have a little about creating modernized agents within Babel, the Rod Johnson framework. So we had a lot of meanings around modernization. It can be a simple runtime upgrade, like moving your code from JDK 8 to 17 to 21 to 25, and also modernizing the Java syntax, like using and moving to Java records. It's part of this modernization process. You can just upgrade the JVM and keep your old syntax, but then you may not have the performance benefits that you have behind the newer versions. Libraries and dependencies, frameworks modernization. I've seen a lot of customers in Brazil moving from frameworks like Struts, or even the previous project that I was helping, it was using JBoss Sim with facelets and rich faces. So yeah, don't smile because then we know your age if you know about rich faces, you know. And then we also have this idea of the paradigm modernization. Companies are like, oh, now I need to move from REST to MCP. That's not like that, but that's a different paradigm, a different way to host your code, and a different approach. But then you may want to reuse some of the logic that you have behind your REST APIs and maybe the semantic or something that you want to move to some MCP server. And also code translation. I did, a month ago, I translated a WhatsApp MCP server that someone built using Go, and I know nothing about Go. And then like I was running and it was stable, but then I said, oh, I need to move to my comfort zone. So I asked my IDE with AI to translate to Java, and it was like one shot. And then, oh my God, this AI is reality, you know, like it was impressive. And then performance optimization. So many times when we talk about softwares, and especially Java, we talk about dependencies. If dependency was a good thing, it wasn't named as dependency, you know? Like it's something that you need to run your workload. So Jasper reports, struts, EJB entity beans, WebSphere, like it's all dependencies that you have in your workload environments, or even like I have a Swing application and I need to move to JavaFX or something like that, or I need to recreate in a web application. So I'm pretty sure that if you are attending our session, it's because you have something to modernize at home, at your company. So anyone would like to tell us about something old that you have in production?
COBOL to Java.
COBOL to Java, that's nice, because COBOL is so deterministic. Java is so strong typed. You are in a great shape. You are in a great shape. Don't worry. COBOL to Java is easy. AI can do it during vacation. Like, don't worry with that.
No, but the thing is, the simpler programs we were able to put it in production. But when it had a lot of like logic, it needs a lot of work in terms of getting the structure.
Nice. Okay. COBOL to Java is very common. Someone else? Let's see here.
Flex to React.
Huh?
Flex
To React. Flex to React. Like moving the user interface from Adobe Flex to React. So many companies, they want to move X to React. React is being like, is taking the market, so that's common use case. UIs are not that easy as backend. I found that modernizing backend can be like much more easier than UIs, because.
What about like a EJB parts? They stick to Spring.
Yeah.
That's also another challenge we are facing.
Yeah, EJB to Spring. That's nice because EJBs, we have the interfaces that can help a lot to reuse the logic. So, yeah.
When you have a customized version of doing it, it is hard because there are things that are embedded. It's not as easy because initially you think it's easy, but when you start realizing it, there are problems.
Yeah. But EJB, moving from EJBs in general, because it's a different architecture, especially if you are like using a Swing with EJBs, and then you have remote proxies, and then like deeper stuff to take care about, and class loading and things like that can be like, I got it. Yeah, EJB is another one. Anyone else has something to heal in production? Okay, all right. So yeah, we do have, as I said, whatever you have, just smile. Java is a strong type. We had a lot of open source projects over the last 30 years, and the models have been trained on that. So all the Java ecosystem is playing in our favor. And so the first thing is like try to understand your dependencies. Be aware of your dependencies. At Amazon and AWS, we are extremely organized. These companies are good for creating mechanism for everything. You want to take vacation, we have a mechanism. You want to create a new project, we have a mechanism. You want to deploy the new project. By the way, the system that we use to deploy any application in production is called Brazil. I'm proud of that because of Amazon, and then Brazil is deploying the application. So yeah, but then we had hundreds of thousands of Java applications. We don't disclose the number, but I can tell you we have so many Java applications in production, and we are all based on microservices. It's a nightmare to manage microservices at this scale, but with the organization that we have at Amazon, it's fine. And then we are taking the advantage of modernizing applications that 80% of our applications doesn't have more than 20 dependencies. So we really take care about how many dependencies per project you have. And I think that is a really nice metric, taking a look at your Maven dependencies and having this number, or establishing a limit of dependencies. Because if your Maven file is too large, there is something wrong. Everything that is too big is wrong. You know, like customers, very often they come to us and say, all right, Vini, you are showing a demo with like a simple project. What else if I have like a project with 20,000 classes and I need to modernize it? So you won't modernize this project before refactoring and breaking into modules. So you have some homework to do. You need to fix something that you're supposed to fix that thing before modernizing. So modernizing is not magic. It's like just having the time to fix the things that you need to fix, and you didn't have the time, and now with AI, you can optimize how much time you spend on that. At Amazon and AWS, we figured out a model that we had a hybrid, like between using AI models and using frameworks, static and deterministic frameworks to take care about the upgrades. So we create an internal tool to help us to modernize, and then we could like modernize hundreds of applications per week. But that's a big company, very organized, with everything that we learned at school about software development, CI/CD, we do at Amazon. So that's a kind of, and then we need to do that because we have so many compliance certifications to put anything in production that we cannot just put the thing in production and not map all the dependencies. And so, but then we, in other hand, we also have customers that we learn that are small companies that they start the conversation with Amazon like, okay, we want to move from EC2 to containers. And looks like a very simple project. But then, oh, okay, let's do that. It's easy. We always say that as developers. Oh, it's easy, 5 minutes, huh? And then when you start working on that, like, okay, I'm going to use containers, but then, come on, this is JDK 1.6. Not good for containers, not prepared for containers. The framework behind is not Quarkus, that is a container native framework, and even the JVM. So, okay, to move to containers, before doing that, it's better to upgrade from JDK 1.6 to 8 and then to 17. Sometimes you don't want to do a long jump from like 1.6 to 25. It's too distant one from other. So you want to move like 1.6, maybe 11, 17, 25, maybe it's a strategy, but then, okay, let's do that. Let's upgrade. And then what you are using? We are using JBoss. Oh, nice. Which version? 4. oh my God, JBoss 4, we need to modernize that. So everything started with this small company with a simple conversation that they want to move from EC2 instances or virtual servers using like King host or something to containers. And then you end up like having a lot of subtasks in this project. And in this specific case, we discovered that it was a conference company. They have a call for papers that they were using that came from Devox conference, built on Scala. And then we discover like Go applications. And so this customer is a small customer, but I used to say that this is a modernization Disneyland because you have everything to work on. Like they need everything. So that's a nice use case, but it's a small company. So what I'm going to show here is how you can use your CLI. I will be using Kiro here because that's the product that pay my salary, but I don't want to have a sales pitch here. Use your coding assistant, use your CLI, and take advantage of that, and please try Kiro, you will help us as well. And Kiro is great, I've been using for a long time. So I did this prompt. So what I have here is a kind of, I have a set of different projects, like JPA project. I have an Embabel agent here. I have a Quarks project, an Old Spring project, a Struts project. So I am faking that I have like multiple projects in some company that I know nothing about those projects. And so instead of learning by myself, what I did was this prompt to create map of dependencies, create a critical dependencies report, a leadership report to convince my team to upgrade, and create a draft plan to modernize and upgrade the apps in this folder. So I did this, I triggered this prompt a couple minutes ago, just to make sure that we have the fresh results. And then we can see here that we have our dependency map. Oops, sorry. Let me close this. Oh, I opened too many windows. Cool. So it was open all right. Cool. So you can see that the CLI, the Kiro CLI generated, analyzed all the projects for me and could look at the critical dependencies, like, oh, this is critical, this is critical, this is critical. And then with mapping all the dependencies for each individual project. And then severity, by severity, like how this is a very high priority in the project, medium severity, and then all the dependence version matrix. That's nice document, yeah. And then we have like a leadership report. Let's see what he did for us. So in this case, we have, look, compliance. So, oh my God, that's nice. That's new. And then it's trying to estimate numbers for us. I don't care about the number. I used to have a manager that he said, like, any number is better than zero, than no number. Like, let's start with some number. So AI can really be very useful to understand the customer's workload, and there are many, many customers that they are not aware about their production workloads. They are not organized as Amazon. In this case, AI is really a very good shortcut. And most of the small customers, they are leaving their daily jobs and they are not paying attention to this small and simple thing that AI can help and accelerate the process. So, and then we also have to use AI and take care with playing dice with AI. I have one code that I love this quote. That is, plant AI and harvest determinism. Like you use the tokens, you pay for tokens to plant tomatoes. And you want to harvest tomatoes. You don't want to plant tomatoes and harvest jalapenos. Yeah? So that's the trickiest part. If you attended the Rod Johnson's keynote, and Rod and I, we are always discussing how to do like determinism, cache, and things like that. So Open Rewrite is a framework that is been in the market for a while. Very nice for automated large scale and then recipe-driven, a huge community. And the guy who created Open Rewrite is here at the conference, Jonathan Schwartz from Modern company. So that's a nice community. And it's been in the market for the past like 15 years, I think. I will not do this demo, but I'm using Kuros CLI with the same set of projects and for some customers as well. And then I ask Kuros CLI, oh, look at this project. Is there any open rewrite recipe I can use to modernize it? Because if AI can help me to figure out on the recipe directory from Open Rewrite which recipe it's good for modernizing the project, I would prefer to use Open Rewrite and a deterministic solution for doing that. And if you look at modernization as when you are rebuilding your house, you can see that Amazon and AWS, when we do modernization there, is like rebuilding a condo of similar apartments. So we can just look at the similarities between the apps and then, oh, this group of apps, I need to use this Open Rewrite recipe. And then I can use AI to figure that out. Once I figure that out, I can just go and using Open Rewrite. So I harvest the deterministic solution from AI. But I'm not like telling AI like, come on, AI, I'm paying tokens, modernize this one, now modernize that one, and they are all similar. So you can have a kind of token economy behind that. So Open Rewrite is just amazing, and combined with AI, it's even better because like a Kuros CLI and all the models in the market, they know very well Open Rewrite, and they will be able to create a custom recipe for you. So try to run away from the non-deterministic behavior from AI. And then you can do hands-on modernization with your CLI and then type yes, no, trust, yes, no, trust. You can do that. But we have customers reporting that they have 50,000 applications, Java applications in production. So you cannot modernize this number of applications like having your developers pressing yes, no, trust, or changing the things and babysitting the model, let's say this way. We cannot be babysitting an LLM for this number of projects. For a small company, it's fine. So in that case, we have some products and solutions, AWS Transform. You can use your agentic IDE for doing that. You can create your own modernization agent using frameworks like Babel. Rod Johnson and we wrote a modernizer agent that we'll be showing later for you. So you can do that. Like, I want to have full control over the process, my modernization process, and I want to reuse that. I want to have a very nice engineering behind that, or I want to create a product for modernizing customers' workloads. So Babel is the answer, and we had that. The modernizer agent is already published. We fixed it this week, Rod and we fixed it to make it compatible with the newer Embebel versions. Azul JVM Inventory is another tool that can flag you unused classes in production. So you can use this tool to plug in your production. And then knowing your JVM in production is very important as well. So here we have some data, real data from real services. This one is a data that when we migrated 3 years ago from Java 8 to Java 17, we don't disclose the service name from AWS. But if you use AWS, it's the most popular monitoring service. So you can see that we have a memory reduction by 50%. So AWS, we create services that we use AWS services. So like probably Bedrock is running on EC2 instances. So AWS is customer of AWS. And when we did that, when we moved from Java 8 to Java 17, we saved thousands of EC2 instances to provide the service for you. So like magic, we didn't change one line of code. We just moved from Java 8 to Java 17. So if you are running Java 8 in production, don't sleep this night. Upgrade it now, because you will save a lot of money in production. And then another monitoring service. So we have a bunch of this data. If you need to convince your manager, your boss about that, we have a specific presentation we did for Devox with many detailed data around that and proxy service. And then now, my almost brother-in-law will show you about like doing optimizations with AI, which means like modernizing and maybe finding where you have some performance bottleneck and things like that.
Which LLMs did you use, or the particular?
We have an autopilot, but then that will try to use the best and the cheapest LLM, but then you can pick up whatever you want from a list of LLMs. I'm not updated because every 2 weeks we change or support new models. Take a look there, but basically it's in autopilot, and then you can change the model as you prefer.
Do you find any like let's say Claude versus GPT? You find one was better than the other, or?
Many times what I find is that it's just different user interface. And the models like answer pretty much, they act the same thing. And you can have different results based on the tools that you have, the MCP tools, but it's basically the models are the big thing behind, and it's more the user interface and the resource that you have. We can have a deeper discussion.
Yeah, thank you, Vini, and great question. We are getting a lot of feedback about Hero and other things that we do at AWS, and our commitment to you all today is ensuring that feedback's captured. So model selection, model choice, and being able to communicate best on what models perform best at the right tasks is something that we will definitely prioritize. Modern Java does not mean fast Java. I want you to hold that thought for a moment. Modern Java does not mean fast Java. I'm going to do a hard pivot over to the terminal here and start a demo. I think all of you would love to see a live demo in action, and I'm going to kick it off right now. I just ran this command, and as I go through this, rest assured in the beginning here, you may not follow what I'm doing. That's okay. I know we're time-bound in the talk, and I want to ensure the demo can proceed as we go through the presentation. But I'm going to walk you through it anyway. So I've just ran a command called ATX, and that's the AWS Transform agent that Vini mentioned earlier. And I gave it a parameter for this early access Java performance optimization. And I pointed it at my legacy Java application. It's already come back and said, hey, I can help optimize this Java application. Do you have any specific requirements? So I'm communicating with an AI agent right now. And I'm going to tell it, just go ahead with the defaults, and we'll get back to that later. Modern Java doesn't mean fast Java, and slow code can be expensive code. And when we think slow, in today's age, right, we have cloud, we can scale. A lot of times, if something takes a second and that's okay for the customer, maybe you wouldn't define it as slow. But what if you could optimize it in this demo today, for example, 5x to go into a fourth or a fifth of a second? That's a heck of a lot faster. The slow code is expensive, so that means more compute, more instances, and more of your time, like your Friday when performance is slow and you're having to troubleshoot at 2 a.m. How many of y'all have used, or I should start with, how many of y'all are familiar with the Java flight recorder or JDK mission control? Keep your hands raised. How many of you have used it in the past 6 months? All right, and did you enjoy it? All right. So for those that aren't familiar, JFR is the JDK flight controller, and it's been available in the JDK since 11, backported to Java 8, update 2.6.2. And it tells you where your app spends the most time on CPU, memory utilization. You can think of the JFR as a black box recorder for your Java application. You collect the JFR, you open it, you look at flame graphs, and then you start the manual work of reading through the source code, tracing call paths, and you can see in this visual here, there's some identifiers about the code and percentage of CPU utilized. You trace through, you try to determine is it the synchronized block that's causing the issue, or is it this regex recompilation that's 3 layers deep that's eating your CPU alive? And mind you, this is 2 a.m. when production is slow and you're having to figure this out. My name is Jonathan, and I'm a developer advocate at AWS. I'm passionate about software development, and I've been writing code since I was 12. My first programming language was Java, and I've been doing all things professionally from software development to now developer advocacy, focusing on automation, developer tooling, and software developer productivity. In the next 10 or so minutes, I'm going to show you something that's changed the way I think about performance tuning when it comes to Java applications. By the end of this segment, you will see an AI agent read a JFR file, map it to known anti-patterns for performance, implement fixes, and then prove it by building the code, testing the code, and you will know exactly how to do this yourself.
How is your agent reading the JFR file?
You will be responsible for running the JFR and getting that JFR recording, and then you're passing it in to the agent. I'm going to pivot again back over here to our demo just to see how things are going. And again, rest assured, if you're not fully following the demo, as I've really gone into it pretty quickly, I will explain more soon. So you saw me kick off the ATX command. You saw me type in proceed, go ahead and move forward. And you can see this agent is now using tools. For example, it's running shell commands, it's reading the build configuration, it's going to make sure it builds, it's going to look for that JFR file. And now it's got an understanding of the code base, and it's able to start seeing what it can do. So I'm going to scroll down and see what it's already picked up. And so it's already done some initial analysis here, and we can see some CPU hotspots, for example, that 70%, and this maps over to our JDK mission control here. I know the JDK mission control is hard to see, but hopefully the other parts are fairly easy for you. And we can see it's already analyzed this legacy Java app. This Java app is something that processes orders. And again, it was built originally in an older JDK. It's been upgraded since to JDK 21 to take advantage of virtual threads. And so we already see some clear things going on right here. And I'll get into this in a moment, but I want to go ahead and let it know, hey, this is the plan that you've told me, and I'm going to go ahead and go with it. However, you also have the opportunity to tweak this, fine-tune it, iterate with the agent per your preferences. So I'm going to let that continue going along. So let's talk about the performance tuning loop. And this is what performance tuning looks like today. So you have that JFR file that you collect, and then you analyze it, right? You're staring at JDK mission control, looking through for those hotspots. In this case, we have that big hotspot, right? 70%, and then we see some other 1%. Those don't seem like too big of a deal, right? We hypothesize what could be wrong, and then we rewrite the code, and we reprofile to see if it's worked. Now imagine we focused on this top one, and we've addressed it, you've addressed it, and then you reprofile, and now these other ones are gonna be eating a whole lot more percentage-wise. And this loop often takes some hours. It could take an extended period of time. Some teams work on this over months. And I don't hear a lot of people talking about this as a proactive thing. Usually when I talk to Java developers and their experience with JDK mission control and JFR, it's usually due to some kind of catastrophe, or they're just completely bottlenecked by resources, for example, capacity constraints. So imagine thinking about this more proactively, and moreover, letting an agent help you do it. So the brutal contrast is you're a developer and you write features, you write code and ship products. But when performance is an issue, you become a detective, a profiler, compiler, all in your head, all at once. And the tools you have, they show you the data, but they don't tell you what you need to do to fix it. Some of you may be thinking, static analysis, right? You don't need AI. You could just prep for string concatenation and loops, or some of the other examples that I may have mentioned already. But the problem is, you may spend cycles of time looking at those things that match the static analysis and fixing code that doesn't really matter. For example, code that runs once at startup, code that runs in a code utility method that maybe gets invoked in production a few times a year. What profiling does is it finds the hot paths, the issues that matter the most. What if I were to tell you that you have something that could read your profiling data, find the hot methods, write the fixes, only for the code that actually matters? And that is this utility that I'm running here. It is the AWS Transform Custom, or ATX command line utility. And this is an agentic AI tool that automates transformations at scale. And so there are pre-built transformations, right, like Java upgrades. Vini mentioned that briefly. Things like JDK upgrades or framework upgrades, and even beyond Java, right? Someone mentioned about the React transformation. You can AWS has other managed transformations, as well as you have the ability to create your own custom transformation. So imagine you have your own internal libraries that other folks adopt, and you upgrade those, and some folks are running legacy ones, and you want to automate that process. You have that opportunity to build that out yourself and then automate those transformations at scale. So stuff like the JDK upgrade is the headline. But I think there's a transformation that may be interesting for this room, because you've heard a lot about using AI to upgrade Java, but AI reading runtime profiling data and writing performance fixes, that's a conversation that's barely started. And so we looked at this at AWS and thought the JFR data source is underutilized within the Java ecosystem. Every JDK generates it, but few are feeding it into an AI agent. And we built a transformation to do exactly that. So here's what it does. You give it your JFR. It's going to cross-reference that with known anti-patterns. So things like I mentioned earlier, the concatenation, the regex, unnecessary boxing, stream overhead, and type pass, suboptimal collection usage. Those are some examples of these anti-patterns. And it's going to write targeted fixes only for the code that actually matters. So it's going to leave the cold stuff alone and focus on where it can have the most impact. And it's going to automatically identify, implement the fixes, and then build and test to make sure it works. And any code changes, the agent will then build and test and self-correct if it runs into any kind of issue. So you go from JFR file to optimized code in minutes instead of days. And as Vinny mentioned, Amazon's a huge Java shop. And we benchmarked hundreds of applications to be able to build out this utility. And it's from our own experience and findings that we were able to find the most impactful things that this agent can address. So let's hop back over to our terminal. And by the way, I'll also show you briefly the code from IntelliJ. I know it might be difficult to see, just to show you all that this is an application. It's processing orders. This is built to show some of the anti-patterns. However, these are things that are in production systems all over the world right now. So back to the terminal here, and we can see if I scroll back up to where we were. So you can see it's essentially iterating with itself. I've trusted it to run the tools it needs, so it's reading source code, it's executing appropriate shell commands to test the things. It looks like it's handling the string concatenation and the loop anti-pattern here. And looking at, for example, the leaf samples, kind of getting as deep as it needs to go, all automatically to figure out how to address these hotspots. And so we can see here that it's listed out, for example, some of these anti-patterns. And it's got a series of steps that it's running in this managed transformation. So here is step 2. If we go all the way down, we can see kind of where we're at. So we're on step 4. So now it's continuing to go through things like, for example, this revenue analyzer code, and then automatically implementing these fixes, and then testing and verifying that it works. I don't know if we'll get through this whole thing, but hopefully, as I've pivoted between the presentation and the live demonstration, you get an idea for how the agent works and how it's automatically looking at the source code to map it to anti-patterns to then implement the optimizations. So here's a nice visual of like what this hotspot stuff can look like, right? You saw JDK mission control, and you have to imagine yourself in this position of trying to do this manually. And as I mentioned before, it's typically when it's a really tough constraint that you even get to this point where you're wanting to do this. So being able to have an agent do this automatically is really, really helpful, because it's finding the hotspots is one thing, right? Looking at this and going, oh, that's 70%, let's fix that. Oh, that's now the 2% becomes a lot more, let's fix that. Iterating on that and being able to quickly implement the code is definitely a really hard part. So this shows you exactly what I kicked off to initially run this at the beginning. And in today's demo, this may take close to 20 minutes, so we may not completely finish it through, but you're looking at about 10 cents to run this optimization. Now, if you have an app with tens or hundreds of thousands of lines of code, maybe we're looking at a few dollars, right? So maybe amplified a bit. But if you look at the return on investment from 2 points, one being the amount of computing resources that are required when you're running on optimized code, that can be a lot, especially for a scaled production system with a lot of demand. And second, the amount of human effort, right? Developer time is very expensive. So the amount of human effort that's required to fix these things, being able to augment the human to really condense that effort down is a huge cost savings and return on investment as well. And so if I go back to the terminal, I don't know if we're done yet. Okay, so it's continuing through the steps. I see we're on step 5. So it's continuing to rip through this implementation of optimization here. But I want to go ahead and show you the benchmark. So I benchmarked this application prior to the demo, and here's the data. So again, that's a second to run, right? So you may call that slow, but maybe if it's not an issue, it works fine. The customer's fine, you're fine. But in this case, we're able to have significant improvements with these optimizations. So cutting that 1 second down to 200 milliseconds, right? Now the 1 second feels really slow, even if it didn't feel really slow, if you know what I mean. So these kind of things are great for the application working the same, but reducing the amount of computing resources and operating more effectively. So when I ran this earlier, I timed it at 14 minutes. It looks like we've probably been going for about 12 minutes is my estimate, and it's still cooking. Cool, so these are the things you need to know to do this yourself. So you get that JFR recording, right? It's been backported to JDK 8. So as Vinny mentioned, if you're still on JDK 8, you could still potentially have some opportunity to optimize there. But JDK 11, it's supported and up. And you can run this thing in production. And you should consider that because that's where the real data is. So there's less than 1% overhead when you're running JFR. And to get set up with ATX, it's simple, especially if you already have an AWS account. You would install this. If you already have an AWS account, configure an IAM policy in one of those 2 regions, and then you can get cooking as I've done in this demo. If you haven't got an AWS account, really easy to spin that up. And then you point it at your project, give it the JFR file, give it the build context, Maven, Gradle, whatever, and then let it go. The demo today cost about 10 cents. JFR file, ATX, run it, and that's it. What I'd love for you to do tonight or later today is when you go back to your hotel or if you're local, if you're going home, pick a Java service you own, collect a JFR recording, and run the transformation. This is a good opportunity if you have your phone to pull that out and take a picture of this. The QR code there is going to take you to the documentation for ATX. But if you just take a picture, you'll have everything you need to know how to do this yourself. And I have my LinkedIn at the bottom. I'm available at the conference this week after this talk. Also, please feel free to connect with me and reach out on LinkedIn. I'm happy to help answer any questions. And I want to emphasize feedback. As I mentioned right in the beginning of the talk, someone was asking about model selection in these agentic tools. This is early access, folks, so that means we're very eager and actively listening to customer feedback. So when you try this out, what's working, what could be better, please tell me. My promise and commitment to you is I will communicate that directly with the engineers, directly with the product leaders that are working on this. Thank you very much.
All right. It looks like we have some space for Q&A.
Yeah, we can definitely take some questions. Yes.
Maybe slightly unrelated, I have 2 questions.
Okay.
Any means of integrating JFR into Micrometer or CloudWatch or whatever?
The question is any ideas around incorporating JFR into Micrometer or
any other AWS dashboard tooling?
Oh, like CloudWatch. Okay. I don't have an answer to that, but I'm definitely going to make a note and see what answers I can get for you.
Okay. The next question is, when you do the first swing, and you said like you have improved like 60-90%, and then now maybe the next 5% is impacting you, you're going to have to reprofile it.
That's the typical manual workflow, right? I mean, typically folks aren't going to go through the JFR and JDK mission control and like look at everything and then fix everything. A lot of times folks will chip away at like what's the most impactful. Let's chip away at that. Totally cool. Yeah, you can have JFR. You can, yes.
Okay. You have a link for your slides?
I do not have the slides available at this moment, but I'm happy to give them to anybody that wants. Please connect with me on LinkedIn and send me a message.
Thank you, sir.
Certainly.
Question about the transformation. So it seems like secret sauce in these transformations. So it's maintained by you. Is it possible to alter them, add your own transformations, control it?
So you're asking if, let's say hypothetically, you wanted to do something like this without the ATX tool. Is that the question?
No, just those like 27 anti-patterns
Yes.
implemented in that ATX file that you supplied, right? This transformations. What you call this tool? I understand it's just a way to apply this transformation, but secret sauce is in that transformation file, right?
As far as like, it is an AWS managed transformation, so I'm not sure how much like disclosure there is around the anti-patterns. Like off the top of my head, I don't know if that's public or not. However, there's a lot of stuff out there online about these types of anti-patterns that are impactful. And so there's definitely like foundational knowledge here that you can learn and apply whether you're using this tool or not. Does that make sense? Cool. Say that again?
The question that you asked, how do we do to not have ATX? If we just have the recording.
How would you do this without ATX? Right, you can conceptualize how that might work, right? Because ultimately, we have a code base that we're giving to an agent. That agent can be whatever, and especially if you have context about common anti-patterns, like I've mentioned some, right? String concatenation and loops, regex recompilation, numerous others. I think this is being recorded, so you'll have that info if you can watch this later. These patterns are out there, and you'd be certainly welcome to explore with other agents to see what kind of results you get. But like I mentioned, like this has been benchmarked. This is a managed service from AWS. So it's definitely something that we would encourage you to try. But absolutely, these concepts can be applied to other agentic tooling for sure. This gentleman had his hand raised first. Yes.
I have a question about the cost. So it's based on the
agent minutes. Yeah.
Is there like a free trial or something that you can test out without? I know the cost is small, but.
Yeah, if you so this gentleman's asking about costs, and like I mentioned, even this demo, it's pretty inexpensive. So you could be looking at like some dollars to evaluate this, right? If that's if you need budget for that, like there's different paths, right? If you're like an enterprise AWS customer, talk to your account team. That would be my first recommendation. If you're like an independent developer or a small company that's not even affiliated with AWS or use.
In our company, we already have a representative of AWS.
Okay.
We talk to them to check.
You should definitely talk to them about this use case and say, hey, I'd love to do this. Could I get some credits? I don't have an answer if they would give it, but I'm inclined to think that they would work with you to experiment, and at the very least, like the account team will help, fill in those gaps. I would personally recommend if you're not affiliated with, like, if you don't have an AWS account team, for example, you can definitely reach out to me on LinkedIn or outside of this, and we can discuss what you're trying to experiment with, and I could definitely potentially give you some credits, AWS credits to evaluate it yourself. Because again, like a little bit, just a few dollars would be able to test it out.
So
Yes.
let's say we have a lot of microservices running. So I do, as a developer, know the anti-pattern which I want to specifically feed into agent. So
Yes.
If cost is an issue, so I can just feed that specific anti-pattern to the agent, and then we can bring down the cost, right? Because anyway, it will not be scanning for the whole repository.
Certainly, if you so let's say in this app, it's not a huge app. I mean, there might be like some thousands of lines of code. It's certainly not tens of thousands. And so your question is, can you tailor the agent to focus in certain areas or for certain anti-patterns? Absolutely, and I hope I was able to convey that when I showed the terminal and I was just telling it proceed. The terminal, there's two modes. You can do this non-interactively, like we talked about running this at scale. You can envision how to do this at scale automatically, right? That's non-interactive. The way I demonstrated today was interactive. So it's telling you everything it's doing and that it's engaging with you periodically. Like those two moments of like, here's the initial thing, anything you want. You could, at the initial thing, you could definitely say, hey, focus on these Java files or look for this specific patterns and only do that, for example. You can direct the agent to prioritize what you want. And that certainly would, at least hypothetically, reduce the amount of agent minutes, which would reduce the cost.
Yeah, thanks.
You're welcome. This is an AWS managed service, so the service is called AWS Transform. And the command line utility is AWS Transform Custom. So that ATX command is an AWS managed service. And if I pull up this slide, you essentially, one command install, but you will need to authenticate with the AWS CLI. So you'll need ATX installed, and you need, as a prerequisite, the AWS CLI installed with credentials set up.
So you can't run in local, basically.
It does run locally, but you have to acknowledge that
Do the refactoring once you
this is running inference on large language models. So those aren't running locally. So this, like the actual terminal commands, the actual like shell commands, the build stuff, all that's local. But like as far as mapping to, and as far as all the large language model inference, that is happening securely in the cloud. So the stuff is securely sent to the cloud for that type of analysis and communicated back to your local. And then everything's discarded. So like we're not looking at the data to train or anything like that. It's all sandboxed, your data, you own it, and then after this is done, discard it. In terms of the cloud side of things, if you're curious about how things work beyond local.
I guess you could not really translate the code where the issue is, right? It's not transferring.
Correct. Yeah, so it's looking at the hotspots. Yep.
That's great. Let's keep it.
You had a question?
I was saying, I guess you cannot run the model, right?
Yeah, the question is, can you run the model locally? With this, what I demoed, yeah, there's no way. In fact, the inference and the model stuff is completely abstracted from your user experience. So there's.
That's part of the transform. ATX, that's part of the...
Yeah, ATX behind the scenes is running inference on the models that it thinks are best for the job at hand. There's no way, at least today, to point it at your own local model. But again, I mean, I could certainly take that feedback back to the product team if that's something that you'd like to explore. I will say though, we're using state-of-the-art stuff and local models. I mean, there's just not enough competing resources to meet that state-of-the-art bar. So maybe down the line, I could see more performant outcomes from local models. But at least in my experience, the local models are nowhere near as performant as these state-of-the-art models that are running they have access to racks of machinery to run this intensive computing. Certainly. Yeah, please connect with me and let me know any feedback you have. Love to help make you successful.